when you participate in competition, it's not that easy because just normal day-to-day Python will sometimes not work. Because if you don't really know, Python is an interpreted language, meaning that it's been converted into machine language during the runtime. So it's not that fast. So if you think about compiled languages like C++, that's way faster in many of the operations. But it doesn't mean Python is slow. The trick here is that you should understand how the internals and the best practices or optimizations you can do in Python. So that's very helpful when you are participating in competitions like this, especially for hackathons, because if you have ever tried coding competitions held by HackerRank, they usually give a higher timeout for Python programs because claimed to, Python is claimed to have lower performance, but it's not the case anymore. Can I please ask everyone to mute themselves?
Harindu or Brian, is there a chance to mute everyone?
Yeah, I'll mute.
Yeah, we are muting.
Yeah, I'm also doing muting, but I think if we can do it once, that would be good.
I will mute all. Praneeth, you can unmute yourself
Yes.
and start speaking then.
Yes. Okay, so let's get started. I will start the session by simply explaining what are the data types we have. So in here, I'm not going to talk about any third-party libraries in Python because if you think about high performance computing that we do in Trivago as well, there are libraries like NumPy, Pandas, but I'm not going to talk about those libraries here because if you are doing coding in a hackathon, you most probably would want to do in pure Python, meaning you have to use standard libraries. So because of that, I'm not going to talk about any additional libraries that we are going to that we can use, but rather inbuilt stuff. So let me start by sharing my screen. Okay. Let me also move the stuff here so I can see everyone. And also feel free to drop the message in the chat. I can check while I'm presenting and I can take some breaks to answer any questions if you have. So use the chat function and also organizers, they can also keep track of the chat. Okay. Can anyone see my screen or is it too small?
Yeah, we can.
It's not too small, right? Okay.
Yeah.
So, okay. You can see my VS Code just to make sure because I'm working with multiple monitors here.
Oh yeah, yes we can.
Cool. Okay, awesome. So after those technical difficulties, let's get back to the topic. So in here, I have demonstrated three main data structures that we usually use in Python, especially for programming in programming contests. The first one is list. I'm not going to go deeper into these data structures because I have an assumption that you already know this kind of data structures, but just for the audience, I will explain um, in a higher level. So a list is a list. So it can hold a list of elements. Doesn't necessarily be the same type. So you can see I have some numbers and you can also have strings and mix with numbers. It's not recommended, but you can do things like this. So a list basically is a list of elements that's in a consecutive manner. So it's one after the other. So that means you can easily iterate through these elements and also access each of the element using the index. So if you know what an index is, or if you don't know what an index is, let me explain. Index is the position of a given element in a data structure. So this is the 0th element, this is the first element, second, third, and so on and so forth. So up until the length minus 1 elements. So in here we have 6 elements. That means the last one is index 5. So I also have another list just to show that it is possible. You can create multiple lists. So there are two main ways to create a list. One is using this square brackets, The other one is you can simply call the constructor of the list like this. So this is more explicit, but this also works. This is widely used if you already have the list of elements that you need to initialize the list with. This is used. If you don't really know the list of elements that you have, but you will add them later. So this is a list. So internally, if you can read, it's a dynamic array. If you know what an array is, it's a consecutive allocation of memory. It's way fast. If you know about C++ or any memory management, all the elements are right next to each other. That means you can access them faster. But the problem is of an array, if you have heard, arrays you cannot change after you define an array. But lists, or rather vectors, if you think about the other programming languages, you can change the size. That means whenever you create a list, you can change it later on. So the other one is a set. So this is very important because sets, if you know mathematics, if you learn in, I think, grade 7, 8, I don't know, maybe something like that, you learn about sets. In Sinhalese, you call kulaka. But you never think about these when you are at school because nobody cares, right, back then. But now when you come to programming, you cannot escape from those. You still use sets. So a set is a unique group of elements. So now you can see there is not unique. They are not unique because I have some duplicates here. But when you define a set, I can show by simply printing them. So I will say my set 1. And what is this? I will also explain these commands, don't worry. 3 data types. So you can see or not, yes. You can see now. So there were some duplicates like this 2. It's not visible or it's not available in the final output. The reason is sets must be unique. So if you remember this O-level mathematics, you see this, right? You say usually when you create a set, there won't be any duplicate elements. So just like that, in programming also, sets, they will not have duplicates. How does this work is, for each of these elements, it creates a hash. So just like HashCode. It's exactly a hash code. So a hash code is a unique number representing the characteristics of this particular element. It's not very simple. There are hashes, if you know, MD5, SHA1, SHA2, this kind of SHA256, these kind of algorithms, they are used to create a unique number to represent a given data element. So whenever you insert an element to a set, it checks if this particular hash code is available in the set or not. So it tries to create this set, and while it's inserting the elements, it see the number 2, it actually is already available in the set, so it does not add this particular element again. So why this is important? If you are writing algorithms, if you need to check if to get deduplicated elements, right, only unique elements, you can use a set. But for lists, it's not possible. You can have duplicate elements in a list. It will still print the entire list. List 2. It will print the duplicate elements like this. Because lists, they are not hashed. That means it can have duplicate elements. So yeah, that's the main difference. And the other difference is because sets are hashed and the way that they are internally stored, I'm not entirely sure. There are 2 implementation of hash data structures. One is a tree, the other one is a hash table. As far as I know, this is a hash tree. I'm not entirely sure. Don't think too much. For your knowledge, the idea behind this is it's way faster to scan a set than a list. I will show, don't worry. I have all the benchmarks ready. It's way faster to scan a set than a list. Why? because it creates a unique ID for all the elements, and it's much easier to check if a given element is in the set or not, comparing to a list, because it does not hold any hash codes. Imagine that you need to check if a number is available in this particular list, then you have to scan all the elements, like entire set. This is fine, this is only 6 elements, but in my work, my type of work, we have around 100 million elements in a given list. It does not work. So if you try to check if a given element is in a list, it will take like, I don't know, 200 years to work. Not 200 years, but you get the idea. It's very slow. So we don't do that. For that, we use sets. Why? Because lookup is way faster in sets. I will also show the benchmarks. Then we have dictionaries. In Python, it's called dicts. So what a dictionary is, it's a similar concept like sets, but instead of a single element, it uses the key value concept. So there is a key and there is a value. So it's like a dictionary, like in literal terms. You have a word and its meaning or multiple meanings. Meaning you can have a key, the value can be anything. It can be another string, a Boolean, a decimal value like a float, another list. It's also possible. And also as the key, you can put multiple types of elements, not just strings. You can put Booleans, you can put double or other float, you can put integers, you can even put tuples, which is the fourth type of data structure. You can put a tuple, but you cannot put a list, set, or another dictionary. This does not work. So in case that you need to keep track of, let's say, records with multiple elements, for example, let's say you have a key, like a primary key, which is can be name and the date of birth, just imagine. So if you need to create a unique set of these elements, you can have a tuple as the key, name and the date of birth or whatever the element you want here, and create a tuple as the key. It works, and you can easily check if a given element is in this dictionary or not. I will show how it works. And how to run a Python code if you don't know, because I'm still struggling to understand the levels, because we have how many people here? A lot of people in this call, so I don't know the exact knowledge level. So I will try my best to cover both of the ends. So if you don't know how Python works, it runs through an interpreter. So Python code, you have to trigger the Python interpreter and ask the Python interpreter to run the code. So this is how you do it. So Python 3 is the new one. There is Python 2 as well. Who's drawing on my screen? I don't know. Then you get Python 3, and also you tell the interpreter which Python file that you want to run. In here, I don't have any main function. It's not really necessary. If you have just like pure dump code, you can easily trigger it like this. If you don't have a main function, it will anyway trigger that. I will explain what the main function later on. So then this works. So it usually works from top to bottom. Usually it can change, which I will not explain here anyway. Okay, let me show how you can check if a given element is in list, sets, and dictionaries. So I can check. I will simply use print function for everything. So print stuff on your screen. I can check if, let's say, 100 in my list one, my list one. Also, I can check 11 in my set one. Print, let's say, name in my dict one. So I will run this, and we don't need this one. So you will see its first one is false, because obviously 100 is not in list one. It does not have it. 11 is in the set. It has the element in the set. And name is actually in the dictionary. So how can we extract elements? So it's very simple. So for a list, you can extract elements using the index. So you can extract the first element like this with 0. You need whatever other indexes you can put. If you put like say 10, this will crash. So don't do this. You can, in a set, which is very tricky, you cannot do this. In a set, you cannot do this. This does not work. Why? Because sets are unordered. So there is another new term. These are ordered data structures, or we call sequences, and these are not ordered. So that means you cannot index them. Yes, it seems like the number 2 is in the first position, like the 0 index, but it's not. If you can, please take a look into how hash tables and hash trees work. Then this will, if you can write this down if you want. Take a look into this, then you will understand what I mean. It's not indexed. You cannot ask the set, give me your first element. It does not work. Same for dictionaries, but it's a little bit tricky for a dictionary because yes, dictionaries are not indexed, but you still can do this. But then it's not the index, it's actually checks for the key. So I will run this and show that this will crash. This crashes saying this is a key error because, oh, this is actually my list. So my autocomplete doesn't really work the way that I want. So the first element is 1 from my list 0, which is correct. My set 0 crashes. Okay, fine. I will comment this. And you will also see the other one also crashes because there is no 0 index, but it actually tells us it's not the index, it's the key. So to extract an element, you have to tell something like this. Then it will say, this is the name. So this is how you can extract data, but in case you don't have the index like this will crash again. To avoid that, you can do .get function. So then this will not crash. Amazing. Then it will still work, but it will print none as the output. If you say .get, and if this key does not exist, it will return none. You can also pass, put a comma at the end and pass another variable, another value here, which is the default value. In case X does not exist in this dictionary, it will return unknown as the value. So you can see it will return unknown. So this is how you can extract values from dictionaries. I hope you understand. If you have any questions, please put them in the, oh, we have a lot of messages. Okay. Okay, let me change the sizes. First of all, you don't have to call me sir. That's very not good. Collections.com. Yes, you can use, because collections are actually a part of the standard library. So you can probably, but I think the organizers can answer this better. But as far as I know, the amount of programming competition that I participated, you can use collections.com. I think it's a counter, not count. So this is how you can do this. This is the another way. The other thing that I want to explain, there are two things that I need to explain about data types. The first one is iteration. So lists, it's obvious that we can use the for loop for I in my list. So why do I always type my list? So then you can simply print I. So I is the element. So this is not a typical for loop. This is a for each loop. So each element will be assigned to I, and then you can print, or I don't know, do whatever you want with this element. So this prints all the elements in this particular list. But there are some cases that you need to, because this is list is indexed, right? So this is indexed. This is a sequence. So sometimes you need to know what's the index that I'm currently working with. So for that, not so proficient people can write something like this, which works. Sorry, my C++ skills are coming out. Which works without a problem. But the problem is, this is ugly. So this count variable now means the index that I'm working with. So I can do this, and instead of I can also say my list count. This works. How this works is I already know how it works, but count is the index now. So it will keep on increasing every iteration, and you can use this particular integer number as the index of this particular list, which is bad, which is ugly. Don't do this. So the easiest way, or the more Pythonic way to solve this is, there is another function called enumerate. So there is a function called enumerate, and you pass this list into this enumerate function. Then this returns a tuple. So you remember tuples, right? Yeah. So this returns a tuple. I will print the I to show what I mean. So this returns a tuple with index is the first element and the value is the second element. So this is very important and very powerful as well, this enumerate function. You don't have to create your own counter. You can easily iterate. So instead of doing this, you can also say my data. This is how you can expand a tuple, right? I cannot obviously explain everything here. So you can expand a tuple. This returns a tuple for each iteration. You can either use a single variable, or you can expand the tuple by adding the same number of variables to match this, the number of elements in the tuple. So this always will have 2 elements for sure. Always enumerate returns 2 elements. The first one is the index. The other one is the data. So this easily prints or extracts the index. So this is how you can iterate a list. So the other way, the other thing is iterating a set. Yes, you cannot get index-based data from sets, but obviously you can get iterate a set like this. The same works like a charm. It also means you can, instead of a list, you can use a set in enumerate function. Am I too fast? Because I don't see any responses or faces or emotions or expressions. So if I'm too fast, please please drop a message in the chat, then I will slow down. So you can enumerate a set as well. This also works without a problem. So yeah, so this is the other way. In algorithms, you have to, when you solve problems, you have to get the index. This usually happens. So don't introduce new variables. Try to use Python inbuilt functions. So the other thing that we should talk about is how to iterate a dictionary. It's mostly the same. So in my dictionary, so there are 2 ways to iterate. So the first one is you can simply have this one and then print I. So this will iterate only the keys. So I can print. So you see it will only print the keys. So when you say this, it's the same as when you say dot keys, exactly the same. So when you try to check if element is in a dictionary, it usually checks if the given element is in the keys or not. So that's how it works. So this is the same. But the other way that you can extract the value. So we need the value, right? How can I extract the value? So the I don't know, straightforward. I don't want to say the stupid word because it sounds harsh, but the other way of doing this is you can extract the value because you have the key now. So how to extract values from the keys? Like this. So you get the dictionary and you pass the key just like we did before. And this will print both the key and the value. Instead of I will say key because it's more readable. Won't Python run, move on with next if there is an error. This is a very, okay, what if we use for I in range? I will come, don't worry. First question, won't Python run if there is an error? For the idea is, the question is, imagine this has an error. Will it run this particular code? Well, I wish I could say no, but it's wrong because it's how interpreters work. But Python is way more developed than that now. Your program will still work if there is an error, but it will crash only when it try to execute this particular line. So imagine I have another file that I'm working with. I'm importing that, but I'm never touching that file. Then your program will still work. But whenever you try to hit that function, then it will crash. There are some cases. I'm not going to explain everything here, but there are some other cases. It will crash even though you are not using that particular function. It will still crash. The reason is it depends on the way you import your modules into your file. If you import the file in a way that it has to scan the entire thing, then it will crash. Regardless if you call the function or not, it will still crash. But the other way is sometimes it only crashes when you try to call the function. So I hope that it understands. So ideally, theoretically, in theoretical terms, interpreters will crash when there is an error and next lines will not work. So unlike compilers, in compilers like C++, compiled languages, if there is an error, the program will even not compile. You cannot even run. It does not work. But in interpreted languages, it will still run up until the place that it has an error. Then it will not run afterwards. So also keep in mind that it's how it works. Does it depend on the version? I have no idea. But I know for a fact both Python 2 and Python 3 has the same thing. So somewhat similar. It means it will still crash even if you don't use the function. It will still crash. But if you are trying to develop something for an algorithm competition, you most probably will write everything in a single file. Most probably, because it saves a lot of time. So then I don't think this is a problem, the crashing or not. What if we use for I in range my dictionary? Interesting. Let me also show that. So in range, so range is another sequence, just like lists. So range returns an iterable, or rather something that you can iterate on, which you can use in a for loop. So the parameters are, there are 3 parameters you can pass in a for loop. Okay, because you are, I hope, okay, before going into that, I will finish explaining iteration on dictionaries. So this is how you can iterate a dictionary. I hope now you understand. You extract the keys. You don't necessarily need the keys because it will anyway iterate keys. When you say something in a dictionary, it will always check the keys, not the values. If you explicitly need to check values, you have to tell values like this. That's how you extract the values. If you just say the dictionary, it will only iterate keys. So then you iterate the keys, you get the key, and each iteration you extract the value from the key. Don't do this because this is slow. Because you iterate the keys and again you ask the dictionary, give me the key value for this key. So it involves 2 operations. It's not like 2 times 3 times slower, but it affects your runtime of your program. If you are dealing with like millions of data in this dictionary, this will slow down. So don't do this. So the best way you can do this is iterate the entire items. So like this. So now I will print the key to show what I'm talking. Then you can see it's still a tuple. It's still a tuple. It returns a tuple. The first element is the key. The second element is the value. So because it's a tuple, you can obviously extract that. So you can expand the tuple into 2 variables, and this will get both the key and the value in a single iteration. You don't have to ask the dictionary again to give the or the extract the value. So this works without a problem. So the other thing, it mostly have to do with list iteration. I've seen many people do that. So they are using range. So there is another class called range. So range is a sequence. So there are multiple sequence based types in Python. The first one is list. The other one is a string. String is also sequence based. It means this is just another list of characters. I will also explain it in a while. The other one is range. And also the other one is tuple. In here, we only have used a tuple here. But I will also another thing, just hold on. I will explain how we can iterate a tuple as well. So the other one is the one that we were talking is the range. So range generates a sequence. That's the only thing that you have to remember. Range generates a sequence. So you have to tell where to start and where to end and the step. So I will just print and show what I'm talking about. So so you can see it prints 0, 2, 6, and 8. It does not print 10. So it means it creates a sequence. This is not a list, so don't mistake, but it is like a list. It's not a list, it's a sequence. We call them sequences. So 0 up until 9, meaning 10 minus 1. So always the start and the end. So it will generate a sequence between start and end minus 1, with a step of 2. So step means how many steps that you take when you are going to the next element. First one is 0 for sure. The second one, ideally it's 1, but now because you have marked it as step 2, then it goes not to 1, but to 2. So then after 2, it goes to 4, 6, and then 8. It tries to go to 10, but the range defines it will only go up until 0 to 9. So it will only print up until 8. So this is another way. So the question is, can we do this? Let's see. My guess, I don't think so. Yes. So this does not work. The reason is either you have to put 2 variables, 1 variable or 2 variable or 3 variables. It should be integers or then I have to go in deeper, but just imagine they are integers. So you have to put the start and the end, but you are now trying to put a dictionary, which is not an integer. This will not work. Why? You cannot create a range out of a dictionary. But I have seen for dictionaries, this just does not work for sure. But I've seen people iterating using lists. For lists, they try to do this. Obviously, this also doesn't work. But you can iterate a list like this. So you start from 0, you go until length of this particular element. Okay, this works. So that this means this returns a number, right? So length of list 1, which is how much? 1, 2, 3, 4, 5, 6. So this should print up until 0 to 5. So this works like this. And then you can again use my list into ith index like this. This also works, but why bother? Even lendic will work. Okay, let's answer that in a while. Why bother using range when you can simply iterate a list? So the thing that you need to understand here is, so the question is, can we put mydic here? But don't just do stuff just because you can do stuff. Try to understand what does this mean. So this means that you are trying to create a sequence from 0. The length of dictionary is number of keys. This is for sure. When you say just the dictionary, it usually means the keys. So 1, 2, 3, 4, 5. So there are 5 elements, 5 keys. So this returns 5. Okay. Now what? So what are you going to do with this number? That's the whole question, right? That's the whole point. What are you going to do with this number? It does not make sense because you cannot index a dictionary. You cannot do this. This does not work, except if your dictionary has the integer, whatever the number that you're putting as the key. So imagine your dictionary is this. Oh, well, it only had 5, yes. If you had your dictionary like this works. Okay, not sure, let me show you. This works. But if you have keys like this does not work because you cannot index, like call an element out of a dictionary using an index. Does intelligent loop solve them? Solve them? Oh, Sanjay, please explain what intelligent loop means. Because I don't know everything. So just put a message. What does intelligent loop means? So this is how you can iterate a dictionary, a list, and a set. I hope that you understand the differences between a list, set, and a dictionary. Also, let me explain what a tuple is. So a tuple can be defined like this, using parentheses to whatever you want. You can put multiple data types here, no problem, works like a charm, no problem at all. Then you can extract values just like you do for a list. The only thing is you cannot change a tuple after you create it. The tuples are fixed size. You cannot change a tuple after you create this. So you can do this. This will print whatever the index that you are trying to extract. So this is just like that. It works. So tuples are highly used for database-based programs, or you need to create multiple, like you need to create a key with multiple values. So this is something you can use. So yeah, that's pretty much. I mean, you will be surprised if you dig deeper into Python. In Python, almost everything is represented as a tuple. So the function parameters, everything is a tuple. The value you return from a function, it's also a tuple. So there are many things that you can do with tuples in Python. So yeah, this is how you iterate data structures. Any more questions? I didn't get a response. Intelligent loop. I don't know what an intelligent. Why not? Google. Let's. Shall we Google? Uh, hmm. No, I cannot find it. So I will skip that function question. Maybe if somebody can explain what it means, I will explain later. Okay. Do you have any more questions related to data types and how to iterate them? Yes. So the last element of the dictionary, the key is a tuple. So whatever you put in the key of a dictionary should be hashable, because you remember, even in sets, each element will be hashed, right? So that means you have to be able to generate a unique number out of it. To generate a unique number out of it, it should be fixed. That means imagine that you put a list in the key. In here you put a list, but you can change a list, right? You can add elements, remove elements. Then each time you do that, Python has to recalculate the hash. Then it does not work. Then it ruins everything in a data structure. Because of that, it only supports hashable data structures, meaning usually fixed data sets. Also sets but not normal sets. There is a special version of sets called frozen sets. So frozen sets also support that. I mean, the name suggests once you create a set, it's fixed. Then you can use that. So how to deal with this is just like you do with a normal thing. But okay, so the idea behind this is when you create a program, don't do this. The reason that I added all these things is to explain what are the different things that you can do in a dictionary. If you write your own program, do not mix these key types. If you want to use a string, use that. If you want to use a number, do that. If you want to use tuple, then only use tuples. So make everything tuples. The first is the name, or I don't know, some ranking or something. Then use tuples for all the keys. Then if you iterate a dictionary for key value in my dictionary.items, then this is very simple. So you just have to extract. So this is the key. So key is a tuple, right? So then you can iterate a tuple like this for I in key, like this. This is a very interesting one. Let me show what I mean. This is a very interesting code. So can you guess the output? Well, it's a very weird output actually. So first it prints the key. This works without a problem because first one is name. But now I'm telling Python to iterate the key. So now the thing that I explained came into life, where a string is a sequence, right? This string is a sequence. So you can iterate a sequence, lists, range, and tuples. You can iterate strings as well. So now it tries to iterate the string and print I. So in a string, each element is its character, like this. Like this. So it prints. Then this is done. So I can put something here to denote that I finished. Something like this. So okay, string multiplication. One other thing. You don't have to write a for loop to like generate a string if it's the same. You can simply say a string and multiply by 10. It will create a new string with 10 stars. You don't have to do that. It's very, very handy. Remember that. So name, it iterates the name. Alive, iterates the characters. Height, iterates the characters. Hobbies, iterates the characters of the key, okay, not the list. And then comes here, the last element, it's a tuple. Now this is tuple, it's not a string. So then you can iterate. When you say for I in key, now each element is this element. So now it iterates elements of the tuple like this. So you can handle these kind of situations like a loop, or you can directly extract stuff like, for example, you can print, because usually these are sequences, you can extract values like this. This works. You can run this and see what I mean. So you can use indexes because these are sequences. So you can use indexes here. So this is how you can check that. I hope that I answered the question. Okay, keep the questions coming. I will answer them later because we are running out of the time is going on. So the next thing, this is also very, very important, is list comprehension. I will explain it before going into that. I will explain the performance. Why bother? Why bother with all these data structures? So okay, so I have written a code. Obviously, I wrote it beforehand because I didn't want to spend time here. So I have data sets. So I have 4 data sets. Data set 1, S, data set 2, S, data set 1. So this has 100,000 elements. This also has 100,000. Yes. This one has 1.82 million records. Actually, this is a sample from my work. I asked my team lead if I can use that. He said, okay, fine. So this has almost 1.8 million records. These kind of things we deal every day. The other one also, I truncated to match the same number of elements. It also has the same number of elements here. So what we are going to do, we are going to, so I have two data sets. I need to check what are the common elements of these two data sets. So I have data set 1. So to give an idea, data set 1 underscore s is a subset of data set 1, because I definitely should not run for the entire 1 million for lists, but spoiler alert, but just to make things easier, I'm using that. So dataset 2 underscore s is the subset of dataset 2. So let's try to understand the code. So I create two lists, get the current time because I need to compare the timing. First, I cannot really explain everything here, but I will try my best. I'm opening the file with the context manager with, then I don't have to close the file, because when you open a file or any file descriptor, meaning network, can be a file, can be any hardware related stuff, you have to close a connection. So this creates a file descriptor or so-called a connection, then you have to close it. But with context managers, you don't have to do that. Whenever it goes out of the context, it automatically closes. So what I'm doing here is very simple way, read every file, every line in the file, append each line into my data set. So this is a list now. So I'm appending that. And then also doing the same for dataset 2 underscore s. So at the end, I'm checking if a given number is in dataset 1. Okay. So this is our task. But this is exactly not the final output that we need, because my final output should be, I have two data sets. I need to check the common or rather intersection of these two data sets. But for the first step, I will load this and check if this particular number is in this data set. So I will run this Python 3 what is this, compare. So way faster, right? I mean, in a split second, you can get if there is a data, an element in a data set, in a list or not, no problem. So let me change this to remove underscore s. Now we are going into 1.8 million records. So I will run this now. Now you see it's a bit slow, but still searching is way faster, right? This is way faster because linear iteration of a list is fast. Okay, linear iteration of a list is fast, but there is a problem which I will explain now. To exactly know how much time it took, I will check this one here to check, and then I will print the difference. So I want to get how many nanoseconds. So time underscore ns. Can we use data frame? Obviously, we can use data frame. But as I mentioned, I am trying my best to avoid using third-party libraries, because a data frame, I think you are talking about either NumPy or Pandas. So those are third-party libraries. So most probably for computations, you cannot use them, because when you submit the code, they have to install all the libraries. Okay, that's the first one. The IDE is Visual Studio Code. I don't know how to give permission to record. Line 13 and 14 to avoid blank. So no, this is not to avoid adding empty lines, but it also works. But if in any case, this is a very dumbed down version. That's what I said. That's what I meant. This is very dumbed down version of how to read a file into a list. There is a very easy way of doing it. I will also explain that, but this was not meant to do that. The reason that I added this is to stop this while loop. The other way of doing this is you can directly say dataset1 is file dot read lines. So this is the other way of doing this. But I didn't do that because I want to explain this operation. It should call, in my case, I want to show the cost of this append operation. That's why I did not really do a read all. So this one. So I will print time underscore ns is the nanoseconds from epoch. If you don't know what epoch this is, please Google. And you need time, import time to work with this. So I will print the difference, like the current time and the start. So now you can see it took this much of nanosecond. Remove this, then it's microseconds. Remove this, then it's milliseconds. So 46 milliseconds. This took 46 milliseconds to check in 1.8 million records if a given number exists or not. This is a list, so it has to scan every element. But comparing to its this way of scanning, it's still faster. But let's see if what happens if this is set. Okay, if this is set. This is the only thing that you need to change, and also how to append. It's not append anymore, it's add. So dataset2.add. Now you are adding the line. Now I will check if this particular number, I will check actually a number that really exists. Maybe this one. I will check this one, and then that's it. So, what do you see now? This is the amount of time which it took to scan a list. This is the time it took to scan a set. Now, do you see what I mean? This took 46 milliseconds. Yes, milliseconds. This took only 17 microseconds to scan 1.8 million records. Okay, so now you see the difference. This is how much faster? I don't know. Do the math. 100 times, whatever the times, it's faster to scan in a set. But this is not the problem. We are still not there. The problem that we are trying to solve is we need to get the intersection, meaning I need to scan one data set and to check if this particular element is in the other one, right? That's the logic. So this is the dumbed down version I have. Don't do this, but just so you know, just for fun, this is what you can do. I'm scanning the dataset 1. For each element in this, now this is a set, okay? Now this is a set. For each element in a set, check if this particular element is in dataset 2. So for each element in dataset 1, I'm checking this element is in dataset 2. If it is in the dataset 2, I'm adding it to a list. This can be a list, this can be a set, does not really matter. But the idea behind this is I need to get it to a list. I will keep this as a list because I need to only compare these two data sets. I don't need to change this one. So let's keep it like that. So I need to compare the time now. So I want to get the start. Where is the start? I will get the start again here to make it more fair. So I get the starting time here and do whatever I want, get the intersection, get the end time, get the difference. This is actually divided by million, so it is microseconds. And also the intersection, length of intersection, meaning how much elements are actually in common. Okay, let's run this. There's 2, done. So it took 780 milliseconds. Is it milliseconds? It's milliseconds to scan, to check if a given element is in both of the data sets. I mean, you don't have to do this because these are sets, right? You don't really need to iterate them. There is a set intersection function, but I will explain that in a later after this. But if this is a list or whatever iterable, this is how you do it, right? So you check if a given data set, the element is in data set, for each element in data set 1, you check if this particular element is in the other data set. If it is in the this particular both of the data sets, then you add it into a list and then check. It takes 780 milliseconds, which is way faster. Don't forget, both of these data sets have 1.8 million records each. Now the fun part. Let's change this. So you can either do this or this way, it doesn't really matter. I will change this one. And I mean, technically I should not run this because my computer will crash, but just so you know, I will use the this one, the small data set. Okay, now we are talking about 100,000 records each. For the sets we did 1.8 million. Okay, so now we are dealing with 100,000 each in the data set, and I'm using a list. So it's running and it's still running. This will probably run for a few hours. So I will not let it run. I will stop this. If you can hear, my fans are laptop fans are actually starting to spin. So I will stop this. So now do you see what I mean? When you scan a list, linearly is faster, but if you want to iterate two lists at the same time, this is called a nested one, then don't do that. Not even, doesn't really make sense. So I did this experiment with 1.8 million as well. I'm not sure if you will believe me or not. I ran it 6 p.m. in the evening. The next day, 1 p.m., it is still running. It was still running. Yes, I will answer that question. It was still running. So it took more than, I don't know even the progress. To compare these two sets, it took even more than 12, 13 hours, it was still running. So I don't know how much time actually it takes. I don't really want to try that out. And yes, it's related to big O notation. Why? Because when you iterate a data set, it's anyway big O n. Doesn't really matter whatever you do. If you are iterating a data set, it's always big O n. If you go until the end, for sure. Then for a set, this is the tricky part. For a set, if this is a set, if you are checking if a given element is in a set, it's constant time. That's what I meant. I'm not exactly sure if this is a tree or a hash table. If this is a hash table, for hash table, this is constant time. So we go 1. We go 1 if this is a hash table. So iteration is anyway we go n. But if this is a hash tree, then this is big O log n. Log n. Why? It has to travel through the nodes to extract the value. So it always, the average case, a big O case is it will travel through log n. But it's still faster than this one, way faster than big O n. So now I think you understand at the end, what we are trying to achieve here was this one, obviously big O n, this is, you cannot really change anything. But if you are using a list, it again becomes big O n. To iterate that, at the end, it results in big O n squared, meaning it's exponential. Don't do that. For algorithm computations, big O n, if you see big O n squared, run. Just run. Don't do that. If it's log n, probably. If it's constant time, yes, for sure. So this is how I demonstrate. So the only thing that I want to demonstrate here is sets and dictionaries are way faster to scan, but I don't have time to demonstrate this one. But the tricky part is to append, to do a normal append and to do a normal iteration like this iteration. Lists are way faster because whenever you create a new element in a set, it has to hash. If it's a tree, then it has to do insert into the tree. It has to rebalance the tree. Then it takes a lot of time. But in a list, it's just adding at the end, done. So then now you have to understand where you should use each of the data structures. You know, dictionaries doesn't really make sense. You use dictionaries for everything. It's not good. So don't do that. Know the tools, know the data structures, and decide where you want to apply them. Okay. What sorting algorithm you think is best for these kind of questions? Counting sort. What do you mean by sorting for these kind of questions? Because we don't need sorting here. I don't know. Can you explain the question? Mean, yes, for coding competition. What do you mean? Well, I'm coming to sort. Don't worry. So there is a sort. We have this, but don't try to implement your own sorting algorithm in programming competition. Don't do that, because there are computer scientists, software engineers working for tens of years and trying to optimize code and adding into the standard library, and you want to implement your own sorting algorithm. Don't do that. Just use the inbuilt sorting functions, unless it specifically says that you have to implement your own sorting algorithm. The fastest one that I know, there are two things. One is quick sort, the other one is merge sort. So it depends on which type of memory consumption you need, because merge sort takes a lot of memory. If you do in place, it's fine, but there is another way of quick sort. But both are n log n. But unless it asks you to implement, don't implement your own sorting algorithm. There is a function called sort, like sorted in Python. Just use that. We will come into that in a while. The other one that I wanted to explain is comprehension. This is also very important. If you are dealing, especially dealing with a lot of data. So I will still use this one for the moment. Okay, I will create a new file. I will save this one called comprehension.py. I will save this here. So now I have a data set, right? In here I have a data set. So data set 1 is a list. So I need to generate another list out of this particular list. Okay. So the reason that I added this one is that I need some data set to work with. I don't really need to want to add millions of rows here, records here. So now I have a data set here, like called data set 1. So I can print the length of data set 1 and 3 comprehension. So it has this amount of elements. So I need to generate another list out of this list. So the stupid way of doing this, oh, shit, I said the word, but the not so efficient way of doing this is data set 2 equals empty for element in data set 1. Imagine I only need let's say even numbers, odd numbers. So I need to check all the elements if they are even, let's say even, if they are even, meaning divided by element modulus by 2 equals 0. So it's even. Then data set 2 dot append element, and I will print the length of data set 2 just to check how much time it takes. I'm going to first import time and this one. I need to check the time taken for this. So end equals also time dot time underscore ns, and I will check the duration, which is end minus start divided by 1 million. Too lazy to type 06. Okay, so this is the power operator in Python, if you don't know. So I'm going to check how much time this takes. So the idea behind this is I have a data set. I don't count the time here because it doesn't really matter, because this will take whatever the time it takes. But my idea is I need to check the time that it takes to filter one, iterate one data set and do whatever the condition and add it into a different data set. Now, let's try comprehension. I forgot. Sorry. We need to convert this into int, because this is a string in a file, because we didn't really check. Oh, why not? We convert this into int here. So you can directly append an int itself by converting it just into an int in while adding to the initial data set. So it had oh, there's a lot of even numbers, 1.6 million even numbers. It took 364 milliseconds to generate this one. Okay, fine. So the other way of doing this is list comprehension, which I will also explain like this. I get the start, but don't need this. So list comprehension means you comprehend, in English terms, but in simple terms, you build a data structure using an existing data structure, but in a more efficient way. Why not just show? I'm using the same variable name, but obviously this will create a new object, so performance will not be affected. I need to create a list, so I create a list here. But instead of doing any for loops after this one, I will simply say I need to iterate for element in dataset 1 and return element. So this is called list comprehension. So how to process this? This means just like you do a normal for loop, this is the same, right? It's exactly the same. How you do it for element in dataset, instead of checking it here, we still don't do this check, even check, but just on adding it to a normal list, everything. For element in dataset 1, for each element, return element, because it's a list, it will keep on adding it to the list. Okay. So I will remove this if condition for the moment. Now this is the same. This will create a new list with all the elements. This will also create a new list with all the elements, but now we are calculating the time difference. Let's see. So can you see the time difference? it's around how much, like 2.5, 3 times faster doing this. I will explain why. So this is the same logic, exact same logic. Iterate the dataset 1, add each element to append. This is the same. Iterate each element of dataset 1, append element into dataset 2. This is how we do it. But this way, which is called list comprehension, you can do set comprehension, dictionary comprehension. It's comprehension. It's way faster to do comprehension than normal um, insertion or append. Why? The reason is this is a function, right? When you say dot append, it's a function inside list class. So there is a class called list, like you do here. I have my German class, so seems like I cannot attend. List, this is the class. It has a function called append. But when you call a function of a class, Python has to go to this particular class, extract the function definition. So there will be a function definition. If I don't know, I can't go inside. So there is a function definition for append with function description, like the parameters it needs and everything. It has to load it to memory. Then it has to pass this value into this function, assign those value into the parameters, do whatever the magic that it has to add a new element, return. When upon returning, clean the memory, because it also has some parameters, right? So it needs to clean the memory that it used for this function. It does everything when you call this, but it's being done 1.8 million times, which is a lot. But in here, what the beauty of comprehension is, that doesn't happen. So all the calling functions and there is nothing like that. It's just pure list creation. It's like, you know, this creation from the root of it, not using methods, not using class functions. So then this creates the list from the ground up, which avoids calling all these functions. That's why it's faster. Even I will run again. See, it's way faster. So almost 3-4 times faster. So in case you have a program that you need to extract some values or create a new list out of a new list, create a new data structure out of another data structure, use the comprehension, way faster. But it only works if the condition is straightforward. So now I will uncomment this one like this. Now I'm only extracting even numbers. So I need to implement this here as well. How I can do here, after this dataset 1, I will say if element modulus by 2 equals 0. This is how you do it. So this is called list comprehension. So this has three main sections in list comprehension or any comprehension. The iteration part, which is usually a for loop. You iterate through a data structure. You return whatever the value you need, and you can put a condition which will be affected or which will be evaluated per each element that you put here. It will only add this particular element only if this particular condition is true. If it's not, it does not add. So I can run this again. So you will see the count is correct. So this is the same count, so you can see, but it's even like twice as fast when you do in list comprehension. So coming back here, so you remember we had lists here, right? So remember this code. So I would rather convert this data set 2 into a set than making it a list. So data set 2, I will convert this into a set. There are multiple ways of doing it. In fact, I will convert this into a data set 2 like this. So you pass the data set 2 as a list into the set, then this creates a new set. Now data set 2 is a set, not a list. Then this performs as same as it performed earlier. To prove my point, compare speed. See, way faster. We are using dataset 1, right? Underscore s. Okay, underscore s. So remove this. Remove this. Remove this. Let's see. Still faster. See, it's still faster to create a set out of a list than iterating a list. Yes, obviously it took some time to generate a set out of a list, but it's still faster. So if you need to do these kind of things, don't hesitate to convert the data types, but also don't overdo that. Just don't convert everything into everything other data type. It will also slow things down, but just understand what the concept is. So the other way of creating a set is using comprehension. You can, just like you did like this to create comprehend a list, you can have this. So then you will say still for element, you can say, I don't know, element I, whatever you want, in dataset 1 and return I. So when you return I, it actually keeps on adding, like comprehending I into a set. So this still works the same way, but this is even faster. So not quite a lot, but 100, 1,600, 1,100, something like that. So I hope that you understand what comprehension means. And also it's very powerful. There is another concept called generators. I will not talk here. If you have time, please read generators. It's even, it's not faster, but it's a more synchronous way. So it's step by step. So just read more about generators. It's usually used in like calling to network, like you want to call an API endpoint, get data. You don't really need to, for example, if you do this, nothing will work until you load entire thing into your list. Otherwise it will not work. But if you use generators, you can actually break that. You can process line by line. You get the line, pass it to the other function, do whatever the processing, come back. You can keep on doing that. So for that, we use generators, and I'm not going to explain generators here. Okay, comprehension is done. I'm quickly going to go for the sorting. Can you upload the code to GitHub repo after the meeting? Okay, sure, why not? Custom sort. Okay, now it's coming into sorting. This is a very, very small data set. But when you participate in coding competitions, obviously they give this kind of a data set for the test case 1, the dumb test case, but it will have 1 million or so records in the final data set. So that's why this sets and comprehension comes in handy. But in this case, we are talking about sorting. So the easiest way of sorting, I will call it X, and there's a function in Python called sorted. Very simple. You pass the data, the new list, and that's it. That's pretty much it. You just print X. Works like a charm. Python 3 custom sort. This sorts without a problem. So it does not matter. This used, if I remember correct, it uses a version of quicksort. So it's nlogn anyway. So this is the fastest sorting algorithm you can get now. There are no sorting algorithms which can go beyond nlogn. That's proven. If you can find a sorting algorithm which can run faster than nlogn, I think you can get the Nobel Prize. But I mean, why not give it a try? So if it's not explicitly asked in the competition or any programming language or any programming task, do not try to implement your own sorting algorithm, because then you will, it's still not low level. Then you are trying to implement something on top of a language which will always be slower than calling a system like a library level function, unless of course you can write a sorting algorithm faster than in log n. If you have that, go ahead. But also, if you want to try it out, you need to understand how sorting algorithms work. Please do try it. Like a computer science student, if you are doing programming, if you haven't written a sorting algorithm by yourself, that's bad. Yeah, that's very bad. You should definitely try at least once or twice in your life. Try to implement an already existing sorting algorithm. But for programming contests, just use the sorted function. But this is very straightforward, right? I mean, works without a problem. But in competitions, you have different types of data, because sometimes you have to pass values into function. You have to get multiple values. For example, imagine you have something like this, something like, oh, did I screw up? Something like this. So you have data like this. So it's a list of dictionaries. Okay, so imagine you have a class like a normal student class in a school, and you have a tuple or a dictionary or whatever defined in a list. So it has a name and marks. You need to sort this particular list using marks. That's your goal. This does not work. You cannot do this. This does not work. You don't trust me? See, this does not work. This operator, you don't even have it here, but internally it uses this less than operator. It does not work on dictionaries, because now it expects every element in this particular list to support this operator. Obviously, dictionaries don't support that. Sets do, but dictionaries don't support that. So this does not work. So then you need a custom sorting algorithm. Yes, you can go ahead and create your own sorting algorithms, but don't, because there is an easy way in Python to do that. So in sorted, you can pass another parameter to extract the key. So there is another parameter called key. Then you can pass a function here. So I will create a function. Let's say key, or to make it more readable, I will say key. And you can pass the function name here. Name without parentheses. You need to pass the function pointer, not the unit. It's not you are calling the function, but you are telling this this particular sorted function to use this function. You are passing the name of the function, not you are calling. You don't call the function. You pass the name of the function. But when you do this, when you pass this key, we call these mapper functions. It will by default pass each element of this data structure into this function. By default, it does that. So you need to cache it. So you need to catch something like, I don't know, element, whatever you call it, doesn't really matter. It will by default pass it. If you don't have it, it will crash. I can also show that. You can run this. This will crash because it says it takes 0 positional arguments, but 1 was given. It by default puts 1 when it's calling this function, but I haven't defined any parameters, so this does not work. So pass is a Python. I don't know why they introduced that. It's a keyword that you can say, I don't have content, so pass. Some weird keyword. So then I can also print each of the element here. I have no idea what the output will be of this sorted function, but I want to explain what I mean here by it will pass each of the elements. So you can see each of the call or each of the element is passed to this extract. The question is, what if we do a conversion? Yes. So I understand where you're coming from, but the thing is, why? Why do you want to do that? Because it's not simple, right? You think, okay, just just convert this data into a tuple and ta-da, everything works. But no, Python internally has to create a new tuple. And do you think it's fast? It's not. Maybe for like 5-10 elements, it is faster, but we are talking about millions of data here. It's not fast. So, and also, if you create, imagine this is you need this dictionary. That's the reason that you created this, right? You need these dictionaries. That's why you or whatever the data provider gave this. So if you create a new data structure with tuples, you already have this data, you are creating another data structure, both will be in the memory. Imagine it's 1.8 million or billions of records. So you are duplicating data in memory. So you should also try to avoid that. So I'm talking from a software engineering perspective, because I've been a software engineer for, I don't know, 5-6 years now. So I know it feels, oh, why not? Just, it's very straightforward. Why not do that? But don't do that, because it's not efficient. The programming is not just about make things work. It's about make things work in the proper way, in an efficient way. So yes, this will work. You can convert these dictionaries into a tuple, but then you are losing the keys. Then you cannot really extract anything out. I mean, then you have to define something like, okay, the first element is the name and the second element is the marks. But also remember, you cannot change tuples. Imagine you need to add a new element here later on, part of your code. For example, imagine then you need to, after all the sorting and everything, you calculate that, you sort this, and you need to add the rank later on, later part of the code, not here. You need to add the rank. You cannot do that, because if you make it a tuple, you cannot change tuples. So this will not work. I hope I answered the question. The short answer is yes, it's possible, but don't do it. Okay, back to the topic. So this prints each dictionary in this function, but obviously this crashed because I haven't done anything here. So this function that I'm passing here should return the key. So the key is the one that's being used to sort. So if you remember the old one, it has integers, right? So the element, in fact, is the key itself. So 1, 2, 3, 5, whatever the value of the element is the key itself. But in here, it's not. We have to go inside of the dictionary to extract the key. So I am returning the key. What should be considered as the key? So the key is the marks of the element. So this is a little bit hard. If you don't know how mapper functions work, it's a little bit hard to comprehend what actually is happening. So how it works? Before sorting, or the sorting condition is defined by this key. Okay. Sorting condition is defined by key. And whenever it tries to sort, it passes, when it has to check, right? So if this element is greater than this element, so this is the function that it's being used. So it uses this function to extract the key and then compare two keys of two different elements, which helps to sort. So this returns the key that I'm going to use to sort, and this will work, but this will only sort in ascending order. So you can see Kali. I had to come up with some names, so my bad. It's 10, and then Mahi is this names does not refer to anyone in real life, just so you know. Otherwise I'll get in trouble. No reference whatsoever. 43 and 51 up until 100. So someone is 100 because someone always is the first of the class, right? If you know what I mean. Then, but my logic should be, I need to get it in descending order. This is ascending order because 10 is first, 100 is last. But what if I need to get it in descending order? Then I need to negate the value. So this is the key of the function. This always checks like extract key element 1 is less than element 2. This is how it internally works. If you check, Python is open source, so you can check the source code of Python. Go ahead and check the source code. It should probably be like something like this. So it calls the function, the function definition we passed to key. It calls one element, get the key, and check if it's greater than the other one. So to negate that, how can we negate this in this way? Because we cannot really change the implementation of the sorted function, right? So the only way that we can change is to make it ascending, descending. We can negate these elements, which we have access, right? We can negate the key. Then eventually it becomes this, you know, the O-level mathematics, negate, and then change it automatically change the sign. Just like that, I'm returning -1 multiplied by element. Now it's in descending order. Simple. So this is how we can sort a complex data structure. And imagine you have to like write this sorting thing like 5 times for different data structures. So the next one is like what not, I don't know, age. You need to sort by age. Then you have to write another mapper function and then pass it to sorted and use the key as that particular one. So it's keep on growing, and you will have, I don't know, tiny function definitions like this a lot. So we don't do that. For that, we have lambda functions. So please read. I cannot really explain everything. What is a lambda function? So these are not AWS lambda functions. This is Python lambda function, or any programming language lambda function. Lambda function is an undefined function which we define inline. That's the simplest explanation that I can give. So I will say lambda, I'm passing x and put a colon, lambda. X is this element is the x, and I will return what I need to extract. So I will say x marks. So this will return x dot marks. Then I don't need this. If I run this, will be in ascending order. If I need it in descending order, I will do this. So simple, but works. That's the beauty of it. So this is how you can sort a custom data structure inline using sorted function. I hope you don't have questions. So let me take a water break, and while you can ask any questions if you have. Using sort is better to save memory than. I have no idea. I have to be honest. I have no idea. So the question is data dot sort is faster? It says yes, in place, but I don't think this is. I mean, this is also in place. It's a new list containing all. Okay, now I understand what you mean. Yes, I will come to that question later. So this is in place sorting. So that means you don't need this. So in place means it changes the data structure itself. So it says stable in sort in place, meaning it will already change the data structure. But when you say sorted, it does not change data. It creates a new data structure and then return. So I think these are two different use cases. If you don't need the original data structure again, then you can do this, but this will also not work unless you pass a key. I have no idea if we can do this, but why not? Let's give it a try. So well, it works. So thank you for bringing it up. So the difference is when you say data.sort, this is in place, meaning it already changes the data list. When you say sorted, it creates a new data structure. So in that case, this is faster because it does not need any additional memory. This needs additional memory because it will create a new list. So yes, this is faster, but if you need to retain the original data structure, then this is obviously this does not work. The other question is, people recommend Java and C++ for competition programming. What is your idea about that? So when I used to, back in the days when we used to compete in programming contest, we never used C++. Yes, it's faster, but the problem is it takes a lot of effort to write a code. It's a lot of lines. I mean, do you think you can really write like a file reading in C++ like this? No, it does not work like that. It's a lot of effort. So I don't really think C++ is the way to go. But when we were programming, I had no idea about Python back then. I used Java because it's somewhere in the middle related to performance, and also it's easy to write. I mean, not as easy as Python, because now I can vouch into that. Python is way easy to write code. But now, back in the days, Python was considered as a slow language, but I don't think it anymore. I don't think like that, because for like my job, I am a cloud native software engineer, or how you call it. I write code on cloud. So, and we process billions of trillions of data every day. We use Python. We don't use C++. We don't use Java. I mean, you can use Java. You cannot use C++, by the way, because almost all the cloud providers, AWS, Google, they don't support C++. They support Golang, but not C++. Because it's hard to compile stuff on cloud, because you have to match the architecture and whatnot. It's super hard. But they support C#, Java, Python, Node.js, and Golang. And mostly people use either Node.js or Python, because it's way faster to implement stuff. And also, they are not slow. They are not slow anymore. I mean, they are not as fast as C++, or maybe Java. I don't know. Java is also slow for me. But it's easy to write code, and also easy to maintain, easy to deploy. So I think it's just a matter of preference. But if it's a competition, if you already know Python, if you know these kind of tricks where you can improve your code, use Python. If you are proficient with Java, then use Java. I wouldn't recommend using C++ for competitive programming, to be honest, unless it's I don't know, very low level, like network based or something like that. But I don't think programming competitions will ever ask these kind of scenarios. Okay, so I hope I will take a few more minutes to explain a sample question. Yes, this is called ice cream parlor problem. I'm not sure if you have already heard about this. If you are actually trying HackerRank or other coding competitions, this is well-known program, well-known concept. It's called ice cream parlor problem. It's a variation of subset sum problem. But subset sum, it's exponential time, so there is no solution to solve it in linear time. But this one, I will explain what the subset sum is. But this version can be solved in linear, or at least in n log n time. What subset sum is? It will give a sum. It will give a number. You need to pick a given amount of numbers. Let's say 5, or let's say 3. You have to pick 3 numbers, or you have to create subsets which adds up to 8. So for example, you can pick 5, 1, 1, and 1. You can also pick 5, 1, and 2. You can also create 4, 2, 1, and 1. So you can see it's growing exponentially. But that's a very interesting problem. Also related to traveling salesman problem. If you know what I'm talking about, If not, please go and do a small Google search. They are very interesting computer science problems, which still don't have any concrete solution for large amount of data. But this is a smaller version, which is the ice cream parlor problem, where you only have to pick 2 elements. So you need to pick 2 numbers which sums up to 8. Okay, so that's the idea. So how can we solve this? This is a very famous problem. That's why I also picked that, because I also want you to relate to this question. But if you don't know this problem, also it's fine. I will explain now. So how can we solve this? The most straightforward, I wouldn't call it stupid or dumb, but normal people will write code like, you get for each element, you will check by comparing with other elements and check if the summation is 8. If you are thinking about that solution, fine, I will take what I said back. Don't get offended, but it's very slow. Okay, it's very slow. I mean, very slow. Why? To iterate, it will take big O n. To check against every other number, it will again take big O n. Because it's nested, it will be big O n squared, which is exponential. Remember what I said? If it's exponential, don't do that, unless it's very small data set. So, but we can try. Why not? So how we do is, I need to get the numbers which matches, right? So for, let's say I in prices, then again for J in prices, and I also need to skip the indexes, right? I should not check the same index twice, because I need to get the indexes. I will enumerate, and I don't know, I P1, and J also P2, enumerate. So what we will do, if first need to check if these indexes are the same. If the indexes are the same, we shouldn't do it. There is another way. You can actually start from in range. You can use in range for that. And as the starting point, you can give I. That's also possible, but this is another way. Doesn't really matter how you do it. This is something because I'm writing it on the fly. I haven't wrote the code before. So I need to first check if the I and J are not equals. So if this is the case, and P1 plus P2 is target, then I will print P1 and P2. Simple, right? Very simple. When you write Python 3, this is ice cream. This works without a problem. You can see 5.3, yes, 5.3 again. It's because, okay, so you are checking this 5 with this 3 and this 5 with this 3. But for the moment, just keep that, think there can be a duplicate. So the idea behind this is this 5 represents, so that's why it's called ice cream parlor problem. No, I'm not trying to use the concept of 3-sum algorithm. This is 2-sum. That's why it's called ice cream parlor. So the concept is that these are the prices for ice creams, okay? And there are 2 people who want to buy 2 ice creams, but they have some money. They need to get it together. So they need 2 ice creams to match their summation. So this is the total money they have. So they need 2 ice creams, but different ice creams. So if one person takes 4, they will not, the other person will not take 4 again. This particular, I don't know, chocolate, vanilla mix, whatever the ice cream, they will not take. That's why I had to put this algorithm logic. So 5.3 again, 2.6, yes, 8, 5.3 again. So 3, 5 again, because now 3 will scan again with 5. This one again with 3 when you are checking, because you are starting from again from the beginning. This. So now you can see this has a lot of duplicates, right? Because you can see this 5, 3, they are legit ones, because this 5 is checked against this 3 and this 3. But when you are checking this 3, it will start again from this one. So I was wrong. I admit. We need in range. We cannot use this, because when you check 3, there is no point of checking it against 5, because we already checked that. For that, let's use in range. 0 until len of prices j in range from 0, not 0, I into len of prices. You can also do something like, I don't know, prices. You can slice the list like this from I. This also works without a problem. So either is fine, like the way you want to try, it's not a problem. So if you know what list slicing is, this creates a new list from this index to end of the list. So this creates a new list, then you can also check that. But to make it more uniform with the previous one, I will use this one, prices, and this starts from I, but I definitely need to skip that, because for the first iteration, it will always check it with it. So I will do this, but then the problem is it will go beyond. So I will do -1. So the idea is I will only check from here to here. This one, check against this. I will not check 5 with 5. That's why I have from like from I will start checking from I+1. And then I will check again up until here, then, because then I can check the other one as well. So P1 actually is prices into I, P2 is prices into J. Oh, man, I wish I had actually have this assigned. Anyway, but let's run. Now you can see the number of outputs are actually lower, because it does not do duplicate checks, like double checks. Previously, you can see 3 was also checked against 5, but now we are not going back. We are only checking forward. But the number of iterations lowered, but this is still n squared, because we are iterating twice, because this is actually sequential. These are not sets or dictionaries. So they are always sequential. That means it takes sequential time. So this is still not good. But this, some of the times, the code or the problem definition says that this is sorted. So these prices are sorted from, I don't know, lowest to highest or highest to lowest, doesn't really matter. This is sorted. Then you don't have to do this, because this is a lot of effort, because this is how much, like n squared means, imagine you have, I don't know, 1 million prices here. I mean, not just ice cream, right? In ice cream shop, I don't think there are a million prices, but could be a stock market, could be some other numbers that you need to check. Then that's why the name says ice cream parlor, but when you see it in a competition, you have to identify what this program is talking about. So sometimes it says these numbers are sorted. Then you don't have to do all those things. Why? Let me explain. I will comment this one, and I will do prices.sort, because I learned something today. I will do for prices.sort. I learn everything, like things every day. So now I will print this and I will explain it here. So now, because this is sorted in here, no, it doesn't really work like that. Now, because this is sorted, this is way easier to check the summation. So the lowest price we can get the summation. Lowest summation we can get is from here, right? From these two elements. Sorry, not the lowest, but the lowest ends are actually here because you have to now add two elements, right? So I will put two markers. So let me copy and paste this here. This is not code, just something. So I will put two markers like this. And I will bring these two markers, this guy towards right, this guy towards left. Now this is sorted, right? So I will start checking. So if these two markers represent a number, right? These two markers represent two numbers. So the first one is, the left one is 1, right one is 6. Get the summation, which is 7. So if it's 7, meaning the target is how much? 8, right? The target is 8. So the target is 8, we have 7. So meaning we need a higher number to get this particular summation, right? So we need a higher number. But the only way we can get a higher number is by moving this marker to the right side. Obviously now it's 1, but imagine you don't have this all duplicate values. But the only way that you can get a higher number, higher summation, is by moving this marker to the right side. Because if you move this marker to the left side, you will always get a lower number, right? If you go to the left side, it will always provide a lower number. So imagine now this is 7. You need to move this marker to this side. Now it's 5. 5 plus 1, it's still 6. It's still lower. So if you need to go, if the current summation is lower, you always need a bigger number. Then you need to move the right, this left side marker, let's call it start, to the right side and do the calculation again. If it's still low, you keep on going to the right side. If it's higher, then you don't bring this back because you already compared that, right? You already passed these numbers. Imagine you are here now. In here, the start is here. So 1 and 6 is still 8. Then this is a compatible pair like this. Then you can print 2 and 6, no problem. You go here again, move the left start to right, but now it's 3 and 6, it's 9. So there is no point of moving this back again because you already covered this number. So we are not doing that. Then what we do is, if the summation is higher, you bring this marker N1 to the left side. Then check. Now this is 5, 3, 8, works. Then again increase this guy left one, because it's 8. You can move this one like less than or equals. This one 3 and 5, again it's correct, but we already compared that, so we don't need that. Then again 4 and 5, which is higher, which is 9. Then you bring this one to this one, then the 2 pointers meet, and then you stop the iteration. So that's the algorithm. I'm not sure if I have time to implement. Can someone please confirm? Because I'm already running out of time. Well, I don't get any response. Let's start implementing then. Okay, I'm totally going to write this on the fly. So mind my mistakes. So what I'm going to do here is I need to create 2 markers, like start is the first element and is the last index, which is prices minus 1. I need to bring this together. So let's do the most dangerous thing in programming languages, which is while true infinite loop. Awesome. I need to check if, let's take the values first. P1 is prices start. P2 is prices end. If P1 plus P2 equals target, then print, not print because we need to avoid duplicates. So create a set. I will say combinations equals a set. I will add combinations dot add. Now I will add a tuple. So within parentheses, you create a new another parentheses, P1 and P2. Because this is a tuple, you can add it to a set because this is hashable. Okay, cool. But what happens if this doesn't happen? This is not the case. If this is less, P1 plus P2 is less than the target, then you need to increase the start, right? Remember? Then start plus equals 1. If this is the other way around, so equals target. If this is the other way around, if this is too low, then end minus equals 1. Also, we need to break when if start equals end, also break, because when the two markers join, that means we are trying the same element, so we need to break. This is the breaking point actually, so this should happen, otherwise this loop will run infinitely. So I will run the combinations, then that's right. Well, that was fast. I still have it, yes. So now you have two combinations, meaning you can get any ice cream, any two ice creams with price 2 and 6, then this will work. And any ice cream with price 3 and 5. The reason that I added a set is because we had duplicates. This is the first thing. But this is the assumption where the data set is sorted, okay? But what happens if it's not sorted? That's the problem. When this is not sorted, obviously you can sort it, but sorting also takes n log n, right? If this is, and you also know that you have to iterate again, right? Then it can eventually become the same runtime. So that doesn't make sense. Because you guys asked this, I will copy this into a separate line, separate file. Now imagine we don't have this. This is not sorted, and maybe it explicitly says that we should not sort. We should only work with this, only this set. Now this is a problem. Can you think how can we solve this problem? So the question is, you have a list of numbers. You need to find this target, two numbers which will add up to this target. You need to find all the combinations which adds to this one, but this is not sorted and you are not supposed to sort. Could be the program, the question does explicitly says that you should not sort, or sorting takes a lot of time. Then how can you achieve this? A counter. Good question, a good answer, but the problem is Hariharan. But the problem is, yes, you can use a counter. So for those who don't know what a counter is, counter counts the number of instances of a given. Okay. Let's do this. Why not? Print counter prices. So the output is 1 occurs 4 times. Okay, a lot of cheap ice creams. 3 occurs 2 times. 5 occurs 1 time. 4 occurs one time, 2 occurs one time, 6 occurs one time. But the problem is, how can you derive our answer from this? So that's why I always say, right? You shouldn't do just because you can do it. You shouldn't do that just because you can do. This is a good, like, knowing, like, given the fact that you know there is something exists like collection.counter, it's good, but it's not useful here, because then you still have to iterate the counts, right? You still have to iterate the counts and keep on adding, which will still create more runtime than it in fact did. So the other, the initial, where you remember you iterate the first thing that we tried, non-sorted way, it also doesn't work because the input size is too high. You remember I compared the runtimes, does not work. So iterating two lists in nested, not good. The other one is searching for all possible combinations. That's the same thing that we tried, right? So the have like iterate prices in a nested way. Then you check each element with each element in the same list and check if the sums match to this target, which is a good solution, but it's very slow. So no. By adding the keys, I don't really know what you mean, to be honest. Any more suggestions? I mean, there can be multiple ways of doing this. So when I say this does not work, maybe it will work, okay? But what I mean is, like, it will not work for higher number of data sets. If you think about 1 million elements, checking for possible combinations, no go. It's the same as the comparison speed that I did. Doesn't work. Okay, without any further ado, I will explain what I mean. This is only one way of solving this, okay? Only one way of solving this. There can be multiple ways of solving this. So that's why I keep on saying this is only one way of doing it. How we can do is, do you know the word complement? So if you know what a complement means, by doing some operation on that particular number to get a target number, you get the complement. Meaning, let's say my operation is addition. So to get the complement, you need to do the opposite, meaning you get the target, subtract the number 5, then you get the complement. So 5 is complemented by 4, right? 5 is complemented by 4. Sorry, my math. 5 is complemented by 3. Then 5 plus 3 becomes 8. You understand? It's very basic logic. So instead of scanning the numbers, instead of scanning, I have 5. Instead of scanning 3, why not check? So we added a list. We keep on checking 5 and then check for the complement. But why not directly check the complement itself without iterating everything? In simple terms, this is what I'm going to do. I am creating, let's say, complements and a new set. And I have to still iterate, by the way. Price for, let's say, price in prices. But this is single iteration, right? Single iterations, no problem, because it's linear. For each price in prices, I'm checking not my rest of the elements. So the first way that we did is we have this again, right? But it's taking a lot of time, so we don't do that. But rather than that, I'm checking if I have already found my complement. So while I'm scanning these numbers, I'm checking if I have already found my complement. By comprehensively, no. So the question is, by comprehensively add to dictionary with the condition sum. Yeah, I will finish explaining this. Can you Nayang Muhandiram. can you please write a sample code at least like pseudocode and paste it in the chat? Then I can understand it better, because otherwise this will take a lot of time. So back to the topic. While scanning the numbers, instead of checking its complement on the fly, I would check if I already have seen its complement. Okay. So the other way of doing this is add this, make this a set. Okay, I will also explain that later. But most of the cases you cannot really change the type of data that you have. But for the moment, without changing any data types, while iterating, I'm checking if I have already seen my complement. So how to check if I have already seen my complement is to maintain another list, right? But obviously then we have to scan the list, which is slow. But now you already know of which data types the lookup is faster, either a dictionary, either a set. So that's why I'm using a set. I'm checking if I already have seen the complement. If I haven't, I push it to the complement. So if complement is how much? The target minus price, right? This is my complement. But instead of scanning it again, so the other way is if I can check complement in prices, right? This is possible. So I check if my complement is already in the prices itself, but this is a list. So when you check this in a list, it will still take linear time. So this is still then big O(n). But instead of checking in the prices, I'm checking it in a complements. I will explain, because we can also convert this entire thing into a set, but that's a different thing. So I'm checking if the complement is in complements, like the set. If it's already in the sets, then I know my combination is price and comp. If not else, then I haven't seen my complement yet. Then I will add myself to the complements list. Then the next time I find, for example, let's say let's iterate through. I will add complements dot add myself. So price. So myself is not myself, but the number that we are iterating. So imagine that I have 5. I'm checking the complement is 3 because the target is 8. If the complement is in complements, this is a set. No, it's not, because it's empty now. Then complements dot add price. I add 5 to the complements. Now I have 5. So I go ahead, 1, go something, and then comes here. Then it keeps on adding all these numbers, right? Then it comes here, it checks complement is 5 now, because target is 8, price is 3, complement is 5. If complement is already in the complement set, yes, then it prints the combination. I hope you understand. If not, let's try to print it. So I will print the complements. Just we don't need the complements here. Let's print this. So now we get this. Try to process this in your head. This is very important. For each of the numbers, I'm saving its complement. Oh, no, I'm checking if I have already found its match in a set. In a set lookup, it's fast. Okay. For sets, lookup is faster. There's no question in that. If this is a list, no, don't do that. But this is set, it's fine. So I'm checking if I have already found my complement. If yes, that means my number plus my complement is the target. So then I simply print that. If not, because I haven't found my complement, meaning there will be some other number that I will be the complement. So now the number is 5, meaning at some point if I find 3, the 5 should be its complement. So that's why I'm adding the price into the set. So this works without a problem, but as you can see, there are duplicates. To avoid that, you already know how to avoid duplicates. So I will create a combination, and this is another set. Instead of printing combinations dot add, create a tuple and price and complement. Then at the end, print complements. So now you have I need to print combinations, not complements. Now you have the combinations where it gives the target. So the other thing that you can do is, why not directly convert this into a set, right? But the problem is you still have to iterate, right? You still have to iterate the prices, which is anyway linear. And yes, it will be faster here. Then you can check it in the prices themselves. In here, instead of complements, you can directly check in the prices, right? Because now this is a set, but it already had a linear operation where you have to iterate the prices. Then it doesn't make sense. And also creating a set out of a list also takes time. This is not fast. You can simply say, okay, it's just one line, but internally it takes a lot of time. It has to create the set, balance the tree, and create hashes and everything. It takes time. So that's why you try your best not to convert between these two types, but only if it's super important, like these kind of situations where you have to convert them into sets, then do that. Otherwise this will not work. But also you could have simply had sets in the first place here. Just like that, try to avoid conversion between, like creating new data structures out of other data structures. Even if you want to do that, use list or comprehension to do that. I hope you understand this algorithm. This is, can I can I get a coupon for your Python course? Why not? I will generate a coupon for everyone here. I will send out a coupon. Well, in fact, I'm working on an English course, which is way deeper than my Sinhala version of my Python course, which will come soon. Well, do you have any questions related to this? I've been talking for, I don't know, 2 hours. 2 hours, and I'm so sure now. Do you have any questions? Because it's done. That's why. I mean, everything that I want to discuss is done pretty much. Can we use max and min for ice cream problem? I don't know. You tell me. Can we use that? How? So that's my next question. How can we use min and max? Because how can we guarantee that, like, you get the min and you get the max, and then what? Okay, Hariharan, I will copy paste here. I'm sorry if you don't want me to copy paste your code here, but I already will do. Okay, didn't break, that's not a problem. Can we, okay, I will first try to answer the first question. Can we use max and min? So the problem is, okay, it actually uses here, but the problem is, so you need to understand, how does min work internally? Like, doesn't it already iterate the data set? So you have to think beyond what you write in your code, because extracting this min is not constant time. It's not dark magic and you just say min, then you don't get the minimum value. You internally, it still has to iterate constant time. If it's a set, it's a tree, okay? If it's a heap, then it's very easy. You just pick the top one, done. But the problem is, it still has to balance the tree to get the minimum and maximum. If it's a min heap, you have the minimum on top. If it's a max heap, you have a max. But still, the problem is, you still have to balance the tree when you say this one, right? Then inside, internally, your code looks linear, but it's not, right? That's the same thing happened in this case. You check this one. So you think if element in dataset 2 is constant time, but it's not, because internally, if this is a list, it has to iterate the entire list to check if a given element is in the dataset. If it's a set or a dictionary, this is constant time, then yes, because it depends on how these operators are implemented internally. You just cannot write whatever you want in your code. I mean, you can, but then it will perform bad, and that's up to you. But so your question is this one. This is not linear. This takes a lot of like it's a text computation. This whole text computation. Then you check minimum and maximum is this. Or you keep on removing stuff on the list. Well, I like the idea. I like your idea, but this is still the same. This is still the same. Why? This still has to get the max, which is still again not constant time. It's still linear, meaning it's still big O n. So even though you think this is, oh, this is a single line of code, so my code is faster, but no, it's not, because this still takes, it still needs to iterate the entire data set to get the maximum. So it's not. And also remove, you are changing a data structure, which is also not good. Because if you think about it, this is a dynamic array. Removing will cause the size to reduce, and it also internally has to do some internal array reduction, which also takes time. So that the whole idea that I need to convey here is Python seems easy. You think, oh, there is a function like this in Python in build, I can use that. Yes, you can use that, but the problem is it's not fast. Because in C++, probably you have to write your own min function. In Python, they already have it, but that does not mean that it's running constant time. It doesn't mean that. So this is fine, but this will fail for large number of data. I don't mind not having break. It's not the problem here. The problem is you are still trying to get the minimum and maximum. So, but again, I don't mean this is the only way that this can solve, right? I'm not saying that the one that I wrote is the best way to solve. No, I'm not saying that. I'm saying this is one of the ways that this can solve. We can solve in a faster way to reduce the runtime. I hope that I conveyed the message that I want. Anything else? I will give 1 or 2 minutes if anybody have any questions to formulate them. And don't worry, I will not bite you. You can unmute yourself and ask the question. It's also fine. But raise your hand before raise your hand if you want to speak, because otherwise everybody will talk. Got any tips on how to look at a question in another POV? Yes. So my first advice is when you read a question, I mean, this happens to me almost every day in my day-to-day work, because the stuff that I do involves a lot of memory consumption and also a lot of CPU power. It's not just like writing a for loop and everything is fine. But what I would suggest is read the question, try to understand the question, what it means, and don't try to apply the stuff that you know and try to solve the question. Because then it's like, you know, there's this the Sri Lankan saying like gamarala gewangediya wage. So you have, you know, these functions, you have the for loops and everything. You try to put everything into like for every question, every problem, you try to apply that. That doesn't work. It will give you an output, but that does not mean it's sufficient. So I would say try to think what is the fastest way that we can approach this. And if there is this kind of a data set, make sure or know beforehand if it's sorted or not. And if you can, put it into a set. If it's not sorted, check if sorting this particular data set will make it faster or not. So try to address the question in that way, not that, oh, I have a list, I will iterate and find that. It will work, but it will be slow. And I wish if I can give more like tips on how to do that. But the problem is it also comes with experience, right? So you face a lot of problems. You tackle a lot of programming questions. Then you know, okay, for this kind of a problem, you can apply this kind of logic. So that's called training. That's called practice. So that's why I said, don't try to use the only thing that you know to everything and make it work. It will not work. So, and also very importantly, do not think writing in a single line is faster. Like, just like I explained here, right? I mean, this is not fast. So you think, okay, it's just an if condition, right? Why it's not fast? Because it's not simple if condition. It has to internally, by the way, if you have in, it's not fast anyway. It has to scan, but unless it's a dictionary or a set. So it involves, it's not atomic. So then it takes a lot of effort. So when every line you write, have a justification in your head. This is the reason I am writing this line. Then I think you can make it more reasonable and make it more efficient. But if you just write like, you have all the equations in mathematics, you just write the equation and apply variables and then you get the answer, it will not work. You can be a better programmer, maybe even not even a better programmer. You can definitely not be a better software engineer. So always try to justify each and every line of code that you write. I think then it will be fine. And also try to look problem in a higher level rather than, oh, I have a list, then I can use a for loop. But try to think in a more high level way. So like I have a data set which I can iterate, because you can iterate a data set in multiple ways, right? So try to think in a higher level, then you can apply the programming terms there. Because otherwise, if you think about, okay, I have a list of numbers, then you immediately think this set of numbers is a list. Then you lose a lot of performance already. So that's why I said usually try to think in a high level, then it will be much easier. Well, career path advice, I'm not quite sure if this is the correct session to address. So yeah, I can talk, probably just drop me a message somewhere. I don't know, I'm everywhere on social media, or we can arrange another session. But career opportunities, the only thing that I can say is do not get limited to programming languages. This is the only thing that I can say. Learn the basics, learn the concepts. Then you can learn any programming language. Just for example, when I came to Germany, the first day that I started programming in this job, I didn't know anything about Python. I haven't wrote any Python, like any Python code. I never tried anything on cloud. So I came to this job like cloud data engineer without knowing any Python or any cloud, but I learned everything. because I knew the basics. So that's what I said. So the question is wrong. Like you learn Java, then what to do after Python? No, do projects. Always do projects. Learn new technologies, but keep in mind concepts are the most important thing. But if you need any more other suggestions, I'm happy to help. I usually reply to all the messages that I get. So drop me a message or ask the organizers to organize a different session. Well, I think that's it. So organizers, over to you. I will stop sharing my screen.
Yes, thank you, Mr. Praneeth, for your grateful lecture. And Harindu will continue the session then. Harindu?
Yeah, Pranita, we got more than we expect from you. Thank you so much for your time, and hope we got all very valuable session from you. Thanks again. Right. First of all, I want to know who are my audience. I'm just launching a poll. If you can please vote, because there are HashCode hubs, so many hubs. So we can give you a guide to join what is the suitable hub for you. I launch a poll. Please give a vote. Can you hear me?
Yes, you're audible, Harindu.
Yeah, no one voting.
Yeah, it seems 87 out of 112 already voted. Others, can you please vote quickly?
Yeah. So this is HashCode. I will share my screen. I hope you will get some issues when registering. Let me share my screen. All right. First of all, this is the short code for HashCode. HashCode. I will share the link. Yeah, I put a chat. So this is the short code. When you go to this, you are redirecting to Google Cloud Competitions profile, right? This is Google Cloud Competitions profile. And here Google are organizing three major hackathons. Sorry, I think there's one more for women's. All I think now for so the first one is Kickstart, and this is the easiest one, and second one is HashCode. It's the intermediate level, and third one is Code Jam. This is a 24 hours competition, like advanced competition. So this is the HashCode. Now we are here. Can you please drop a message who are not registered yet, can you please put +1 for not registered? Yes. If you're not registered, please put +1. Yeah, there are so many. Right. I'm quickly demonstrate some. First of all, somebody requesting to do the session in Sinhala also. Yeah, I will try to do in both. First of all, we need to create Google coding competition profile first. So in Sinhala, අපි මුලින්ම coding competition profile එකක් හදාගෙන ඉන්නවා අලා HashCode එකට participate වෙන්න කලින් මේකට Gmail එකක් තියෙන්න ඕනේ. මුලින්ම මම මෙතන වැඩ කරගන්න dummy email එකක් හදාගත්තා. This is my dummy email for demonstrate for you. This is the if I go to this email, I will have to allow this. Yeah, after I logged, I can see this screen. So this is my registering time. I will quickly demonstrate this. Yeah. That's Sri Lanka. This is the location we are representing. Yeah. This is the location we are representing, and this is the username, like nickname. No, this is yes. This is not the advanced part, so I'm just filling this. Here, location of residence. This is the gender. And if there's a option for, if you don't like to do that, give that information, you can put no. If you have no, yeah, I'm simply giving no. This is the coding preferred language, but there's no issue with when you competing in by a HashCode. මෙතන ඔයාලා පුට් කරන ඉන්පුට් කරන ලැන්ග්වේජ් එක ඔයාලා කම්පිටිෂන් එකට පාටිසිපේට් වෙද්දි මේක අනිවාර්යයෙන්ම මේ ලැන්ග්වේජ් එකෙම කරන්න ඕනේ කියලා එකක් නැහැ. මේක just data collecting වගේ වැඩක්. මේක උදාහරණයක් විදිහට මම මෙතන Python දාලා තියෙද්දි ගිය පාර තිබ්බ HashCode එකේදී මම scenario එක solve කරන්න C++ වලින් code ලිව්ව මුලින් Python try කරා පස්සේ මම C++ වලට shift වුණා කිසිම ප්‍රශ්නයක් වුණේ නැහැ results ආවා මෙතන දාන language එක අදාළ නැහැ මොකද මේක team competition එකක් එක්කෙනායි preferred language වෙනස් එහෙනම් මේක ප්‍රශ්නයක් වෙන්නේ නැහැ පස්සේ වුණත් මේක change කරන්න පුළුවන් මගේ account එකේ edit info ගියාම මේක just creating Google coding competition profile okay not registering to HashCode just creating Google coding competition profile, right? I must run it. Yeah. Wish to conduct. Yeah. This is there are some information you can also if you like this. They are asking, do you wish to contact about your job opportunities at Google? If you put yes, you can put a link in your LinkedIn handle. If you don't like, no. I'm just demonstrating to you, so that's why I put it to use that option. Would you like to receive email notification about participation? I think you are not showing this. Would you like to receive email notification about participating in Google Conference? Yeah, no problem. Would you like to receive other events? Yeah, it's also no problem. This is the prices category. If you can earn, sorry, there's a message. Yeah. This is the message. Sorry, if you after make one single ඔයාලා Google coding competition එකෙන් මොකක්ම හරි competition එකට participate කරලා prize එකක් දිනා ගන්න eligible වුණොත් ඔයාලා දිනාගත්තොත් ඔයාලව contact කරගන්න විදිහ මෙතන දාන්න තියෙන්නේ. ඔයාලගේ address line එක නම ඔක්කොම ටික දාත හැකි. මේක දැන්ට දාලා තියන්නම්. මේක අනිවාර්යෙන් තව එකක් ඔයාලා coding competition එකට participate වෙන්න 16 years වලට වඩා වැඩි වෙන්න ඕනේ. And agree to terms and conditions. Yeah, see, there's a trade profile. I have already told you this is the profile creating, not registering to HashCode. This button is create profile. So I'm creating my coding competitions profile now. Yeah, after I got this window, if I scroll down, no, I don't need to scroll down. If I back, there's HashCode registration open. Now I have, you see, I have HashCode coding competitions profile. Yeah, view profile. I can see if I earn a certificate from HashCode like CodeJam, they are showing our certificates here. This is HashCode. If I go to this, you can register now for HashCode. You have account. First, if you're not login, please log in and you can see the register now button. මේක පොඩ්ඩක් කියනවා සිංහලෙන්. ඔයාලා මෙතන මුලින්ම චෙක් කරලා බලන්න ලින්ක් එකට ගියාට පස්සේ මුලින් මේ වෙනකම් ඔයාලා කලින් කරේ HashCode Google competition එකට account එකක් හදාගත්ත එක මම කලින් කරලා පෙන්නුවේ. දැන් ඔයාලට account එකක් තියෙනවා. හරිද? account එකක් තියෙනකොට මම ආපහු මෙතනට මේ ආපහු මෙතනට දැම්මම ඕන. මම කලින් මේකේ link එක දැම්මා. මෙතන මේ තැන හොයාගන්න බැරි වුණා. මේක ගොඩක් කට්ටිය හොයාගන්න බැරි වෙලා තිබ්බයි. register account එක හදාගත්තට පස්සේ මේ link එකකටම ආයි ගියා නම් හරි. හරිද? මම මේක reload කරලා පෙන්නන්න. මේ link එකටම ඔයාලා ගියාට පස්සේ කෙලින්ම එන්නේ මෙතනට. මෙතනින් ඒ වෙනකොට ඔයාලා මෙතන account එකට log වෙලා හිටියේ නැත්තම් මෙතනින් log වෙන්න account එකට. හරිද? ඔයාලා HashCode profile එක හදාගත්ත account එකට. ඊට පස්සේ ඔයාලට මෙතන register now කියන button එක පෙන්නනවා. මම මෙතනින් register now දුන්නාට පස්සේ මෙතන තියෙනවා අපි කලින් address දීපු ඔක්කොම account එකේ තියෙන අපේ details ටික ඔක්කොම. හරිද? ඒවා verify කරන්න පුළුවන්. නැත්නම් profile එක update කරන්න පුළුවන්. මොකක් හරි මේ update කරන්න තියෙනවා නම් මෙන්න මෙතනින් තමයි ඔයාලා HashCode එකට register වෙන්නේ. හරිද? මම agree වෙන rules වලට මෙතන yes දෙනවා. මෙතනින් තමයි HashCode එකට register වෙන්නේ. කලින් අර account එක create කරා කියලා ඔයාලා HashCode එකට register වෙන්නේ නැහැ. හරිද? මෙහෙම HashCode එකට register වෙනවා. හරි. After I registered, you can see head of the judge system. This button will appear only if you registered. Right? මේ බටන් එක පේනවා රෙජිස්ටර් වුණොත් විතරයි. රෙජිස්ටර් වුණාට පස්සේ මේ බටන් ජජ් සිස්ටම් එකට අපි ගියාට පස්සේ you should have to authenticate. This is a very simple thing, but many people is getting off. Yeah, I just authenticated. Please check your email, which is what email you look to here. And here I have no team yet, right? The thing is, I should create a team now. This is a team competition. So I should have 2 or 4 people. If my team has only me, I'm not eligible to participate our competition. So please පුළුවන් තරම් try කරන්න. ඔයාලා team එක waste කරන්න එපා. 4 දෙනාම collect කරගෙන team එකක් හදාගන්න. මුලින්ම team එකක් හදාගන්නේ මෙහෙම. මට මෙතනින් ගිහලා team එකක් හදාගන්න පුළුවන්. මේ team එක හදන්න ඕනේ එක්කෙනයි. හරිද? මෙතන දෙන්න. ඕන් ගන්නම දෙන්නම. මේ මගේ team name එක. ඔයාලා පටලගෙන ඉඳන්න. කැමති නමක් මෙතන දෙන්න පුළුවන්. හරි. මම මගේ ටීම් එක හදාගත්තා. හරිද? හරි. මේ තියෙන්නේ මගේ ටීම් එක. මෙතනින් පුළුවන් මට ටීම් එක රීනේම් කරනවා නම් රීනේම් කරන්න. හරිද? මෙතන දැන් ටීම් එකේ මමනේ හැදුවේ. ඉන්නේ මම විතරයි. I'm the only member of my team. So I should add others to my team. So there's a inviting link. I can simply copy this link and put my friend to join our team, join to my team. So, anyone? Yeah, this is a demo account, so no problem. I pasted that link to chat. If you anyone to check this, can join. කැමති කෙනෙක් ඉන්නවා නම් join වෙලා බලන්න පුළුවන්. අපිට check කරලා බලන්න පුළුවන්. එතකොට ඒක ප්‍රශ්නයක් එන්නේ නැහැ. දැන් මේකට join වෙනවා කියලා පස්සේ ඔයාලට remove වෙන්න පුළුවන්. leave team දෙන්න පුළුවන්. කිසිම ප්‍රශ්නයක් නැහැ. මේ හරි. මම ඔයාලට දැන් පෙන්නන්නේ hub එක create කරන විදිහ. hub එකකට join වෙන විදිහ. sorry create කරන විදිහ නෙමෙයි. මේ තියෙන්නේ අපේ my team judge system එක. මෙතන මම reload කරලා බලමු තව කොහොමද ඇවිල්ලාද කියලා. Yeah, there's no one yet. This is the section you can choose a hub. You can participate to this HashCode without a hub or with hub. There's a lot of opportunities by joining virtual hub. So you can select the hub. You should choose a hub first. This hub called in Sri Lanka. Yeah, if you choose Sri Lanka, you can list of Sri Lankan HashCode hubs, right? There are small HashCode hubs. In first communities, we have HashCode hub in IIT and SLIT and UWLS University, but it's not approved yet. Maybe in this 1 or 2 days it will approve. After you can join. Now we have first NSBM hub and first LK hub and IIT hub and SLIT hub. Right. There are people who are not from that universities. If you are not that universities, for university, if you don't have a HashCode hub, you can join for Sri Lanka. It's not a problem. There's no restrictions. You can get the hub benefits from for Sri Lanka. If you competing, if you get a place, you can win some items. Right. there's a for Sri Lanka, and also if you are representing for NSBM, if you are undergraduate from first NSBM, for example, you can choose first community NSBM, and so there's more hubs. I'm selecting for Sri Lanka now. If I select this, simply I am asking, do you want to join this hub? Yes. Yes. Yeah, there's one person. Thanks. Right. There's you can see your team is registered to participate from hub for Sri Lanka in Sri Lanka. Yeah, it's hub name is for Sri Lanka. So if I want, I can leave hub simply. Yeah, I will demonstrate it also. If I want to leave from this hub, yeah, there's a no hub. Yeah, I can select back. Yeah, I am back in for Sri Lanka hub. So that's the simple theory. If you have any questions, you can ask me. Language is not matter. How to form teams? Form teams. Sorry, I can't understand it. මෙතන මේ ටීම් එක හදන්න ඕනේ එක්කෙනයි මුලින් හදන එක්කෙනා අනිත් කට්ටිය ටීම් එක හදන්න ඕනේ නැහැ. හැබැයි මේ ජොයිනින් ලින්ක් එක අරගත්තට පස්සේ මේ ලින්ක් එකෙන් පුළුවන් ඔයාලට අපේ ටීම් මම හදපු ටීම් එකට එන්න. මම ඒ ලින්ක් එක තමයි chat එකේ දාලා තියෙන්නේ. ඒ විදිහට හැබැයි මෙහෙම මේ ටීම් ලින්ක් එකෙන් ගියාට වැඩක් නැහැ. ඔයා HashCode එකට රෙජිස්ටර් වෙලා නැත්තම්. හරිද? මුලින්ම HashCode එකට රෙජිස්ටර් වෙලා ඉන්න ඕනේ. අර මම කලින් කියපු මේ කියපු ප්‍රොෆයිල් එක හදාගෙන ඉන්න ඕනේ. හරිද? ප්‍රොෆයිල් එක හදාගෙන wait. ප්‍රොෆයිල් එක හදාගෙන HashCode එකටත් රෙජිස්ටර් වෙලා තියෙන්න ඕනේ. මෙන්න මේ බටන් ඔයාලා if හරියට HashCode එකට රෙජිස්ටර් වුණා නම් මේ බටන් එක ඔයාලට ඩිස්ප්ලේ වෙනවා head to the just system කියන එක. මෙතනට ආවට පස්සේ ඔයාලා ටීම් එකක් හදන්න නැත්නම් ඔයාලා වෙන කෙනෙක් හදපු ටීම් එකකට ජොයින් වෙනවා නම් මෙතනින් එහාට ප්‍රොසීඩ් කරන්න ඕනේ නැහැ. ඔයාලට තියෙන්නේ මේ ලින්ක් එක ඔයාගේ ටීම් ලීඩ් ගෙන් ඉල්ලගෙන ටීම් එකට ජොයින් වෙන්න. එච්චරයි. මම හිතනවා තේරුණා කියලා. මොකක් හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න පුළුවන්. නැත්නම් අපිට ටක් ගාලා ඉවර කරන්නත් පුළුවන්. ටීම්ස් හොයාගන්න ටිප්ස් මොකුත් තියනවාද? ටිප්ස් අපි කලින් කිව්වා වගේ again ටීම් එක හදාගන්න අර මම හිතන්නේ මේක අපි කලින් සෙෂන් එකේදී කිව්වා. කොහෙන්ද එහෙම කිව්වේ? ටීම් එක අර ඩිෆරන්ස් ෆ්ලේවර්ස් ඉන්න කට්ටියකින් හදාගන්න කියලා. ප්‍රෝග්‍රෑමින් ඉන්න කට්ටිය ගන්න එක තේරුමකුත් නැහැ. දැන් අද සෙෂන් එකේදී කට්ටියට මම හිතන්නේ හොඳ අයිඩියා එකක් හම්බුණා මොන වගේ මොකක්ද සිනාරියෝ එකක් දෙන්නේ කියලා. කොහොමද ඒක හිතන්න ඕනේ මොකද thinking pattern එක වගේ ඒ දේවල් competition එකේ problems already published ඉන්න මම පෙන්නන්න again into 2021 එකේ problem එක already published නෑ ඒක එදා හරියටම 25 වෙනිදා රෑ 11ට ඔයාලට happy වෙයි ඔයාලට ඕනනම් පරණ මේවා ටික ගන්න in this profile you can scroll down there's all scenarios I will share the link I really like you can also message in not privately like publicly Let me show you the certificate, what we can get. Right. This is my primary profile. If I go to this profile, this is the certificate I earned in 2020. This is the certificate. You can earn this certificate by scoring at least 1 mark. There's a lot of mark, like millions marks scores. Again, million ගණන් මේක score කරනවා කට්ටිය මුළු ලෝකෙම. ඒත් ඔයාලට එක සබ්මිෂන් එකකින් එක මාක් එකක් අඩුම තරමේ ගන්න පුළුවන් වුණොත් මේ සර්ටිෆිකේට් එක earn කරගන්න පුළුවන්. අපි එක පොඩි ටිප් එකක් කියන මම මේක IIT එකේදී කිව්වා. මුලින්ම මම HashCode එකේදී මම දෙපාරක් HashCode participate කරා. In 2019 and 2020. In 2019, I did not participate. Again, only just I know I'm given a scenario and given time. When a time megedi problem is solved කරන්න ඕනේ කියලා විතරයි දැනන් හිටියේ. මොන වගේ ප්‍රශ්නයක් දෙන්නේ කියලාත් මොකුත්ම දැනන් හිටියේ නෑ. But so මම ඒකට ලෑස්තිලා නෙමෙයි ගියේ ඒ පාර. ඒ හින්දා මට ඒ පාර සාර්ථක වෙන්න බැරි වුණා 2019 but මං මෙලොවම දැනන් හිටියේ නේද ෆස්ට් ඉයර් හිටපු කාලේ ගොඩක්ම කිසි දෙයක් දැනන් හිටියේ නැතුණාට මං ඒකෙන් ඉගෙන ගත්තා මගේ එක්ස්පීරියන්ස් එක මම කියන්නේ මම ඒකෙන් ඉගෙන ගත්තා මම කොහොමද මේකට ලෑස්ති වෙන්න ඕනේ කියලා හරිද ඒ කියන්නේ මම කොච්චර දේවල් ඉගෙන ගන්න ඕනද මේ වගේ තැනකට. ඒ කියන්නේ ඔයාලට බලා ගන්න පුළුවන්, ඔයාලව කම්පෙයාර් කරන්න පුළුවන් වර්ල්ඩ් කම්පිටිටර්ස්ලත් එක්ක. ඔයාලා ඉන්නේ කොතනද කියලා ඔයාලට එස්ටිමේට් එකක් ගන්න පුළුවන්. සිම්පල්. ඒක ගොඩක් වැලියබල් දෙයක්. මේ try කරන්න හැමෝම නිකන් හරි පාටිසිපේට් වෙන්න. අතහැරලා ඉන්න එපා. ප්‍රොබ්ලම් එක දැකලා නිකන් යන්න එපා. පොඩි හරි ටිප් එකක් හම්බ වෙන අවසානයේට හරි මොකක් මාරි chance එකක් එන්න පුළුවන්. පුළුවන් තරම් හිතන්න. try කරන්න. මං එක මට බැරි වුණා එක ඔයාලට පන්තර පේනවා මට එක සර්ටිෆිකේට් එකේ තියෙන්නේ කම්පිටිෂන්ස් දෙකකට පාටිසිපේට් වුණාට ඒ කියන්නේ මට 2019 දී එක ලකුණක්වත් ස්කෝර් කරන්න බැරි වුණා හරිද ඒ තරමට මම වීක් හිටියේ හැබැයි මං එදා මං ඒ කියන්නේ ෆස්ට් එක්ස්පීරියන්ස් එක ගොඩකට තීරේ ඒක මොකද්ද කියලා එකට හැබැයි දෙවෙනි පාරදී මං ඉගෙන ගත්තා ඉගෙනගෙන මොකද්ද මේකට වෙන්න ඕනේ මොකද්ද මේක කොහොමද මේකට ලෑස්ති වෙන්න ඕනේ කියලා කොහොමද කියලා ඉගෙන ගත්තා ඉගෙනගෙන කොහොම හරි 2020 එකට පාටිසිපේට් වුණා සෝ අපේ ටීම් එකට පුළුවන් වුණා in Sri Lanka top 10 එන්න top 10 no top 11 sorry top 10 no this is the certificate for it this is scores how much we get right so try again can we participate individually? Sorry, no, you can't participate individually. At least your team should contain maximum 2 members. Sorry, minimum 2 members, maximum 4 members. If you are only in your team, your team will not eligible to participate to competition. Try කරන්න හැමෝම පොඩිම හරි දෙයක් ඉගෙන ගන්න කම්පිටිෂන් එකට පාටිසිපේට් වෙන්න නිකන් ඉන්න එපා ඉගෙනගෙන try කරන්න පුළුවන් තරම් මේකේ බැරි වුණා කියලා අතාරින්න එපා ඊළඟටත් පාටිසිපේට් වෙන්න මමත් මේ පාර පාටිසිපේට් වෙනවා අතාරින්නේ මාරම එක්ස්පීරියන්ස් එකක් ඔයාලට ගන්න පුළුවන් හරි ඔව් හබ් එකට යන එකේද බෙනිෆිට් එකක් තියෙනවද කියලා අහනවා මෙතන ප්‍රශ්නයක් අහලා තියෙනවා සරලවම කිව්වොත් මේ හැම්මෙන් ඔයාලට හබ් එකට ට්‍රූ හම්බෙන බෙනිෆිට් එක මේ වගේ සෙෂන් එකක් මේ වගේ ප්‍රැක්ටිස් ක්විස් එකක් අපි ප්‍රණීතය අද ගොඩක් වටින සෙෂන් එකක් ඔයාලට දුන්නා මේ වගේ දේවල් හම්බෙන්නේ හබ් එකක් හින්දා අනිත් එක අපි දැන් හබ් එකක් ගොඩක් දුරට කරන්නේ මේ වෙනකොට බලාපොරොත්තු වෙන Zoom එකක් Zoom call එකක ඔයාලගේ teams වලට breakout rooms කඩලා කට්ටියට කම්පිට් කරන්න දෙන්න එතකොට ඔයාලට පුළුවන් ඒ වෙලාවෙම live breakout room එකේ එළියට ඇවිල්ලා ප්‍රශ්න මොනවා හරි තියෙනවා නම් අහන්න හරි මොකක් හරි issues තියෙනවා නම් අහන්න ඒ වගේ දේවල්. ඒ පැත්තෙන් ලොකු support එකක් හම්බ වෙනවා hub එකකින්. තව ඒක ඉතින් වැදගත් දෙයක් නෙමෙයි ඔයාලට ඒකේ hub එකට අනුව ඒක depend වෙනවා මොකද ඒ hub වලින් sex වලට හම්බ වෙනවා place එකකට આવොත් ගොඩක් දුරට එහෙම දේවල් තියෙනවා. ඒවත් එක්තරා benefit එකක් ඒකට ඒව බලාගෙන තරම් කරන්න එපා experience එක ගන්න. හරි තම ප්‍රශ්න තියෙනවද?
මම හිතන්නේ අයි අයත් එක්කම තිබ්බ ප්‍රශ්න ගොඩක්ම සවල් කරගන්න පුළුවන් වුණා. ඒත් එක්කම අපි චැට් එකට දාමු කලින් රෙකෝඩ් කරපු විඩියෝ එකක් තියෙනවා හබ් එකේ රෙජිස්ටර් වෙන හැටි අයිඩියාවක් හම්බුනේ නැත්නම් ලින්ක් එකක් දානවා චැට් එකට. ඒක බලන්න පුළුවන්.
ඔව් මම කියනම තවන මේ ගැන් අපි දැන් මේ කියපු ටිකම අපි කලින් සෙෂන් එකක් කරා ඒකේ රෙකෝඩ් එක තියෙනවා අතන YouTube එකේ බලන්න පුළුවන්. ඕකේ අන්ඩ්‍රේ.
ඒත් එක්කම අද සෙෂන් එකට ජොයින් වෙච්ච හැමෝටම thank you. විශේෂයෙන්ම අපේ ස්පීකර් මිස්ටර් ප්‍රනීත් සිල්වා එයාට thank you මේ අපි thank you කියනවා මේ අපේ අපි වෙනුවෙන් ඇවිල්ලා මේ වැඩේ කරාට. ඒ වගේම අපට ස්පීකර්ව හොයාගන්න උදව් කරපු ධනුෂ් අයියා ෆොස් LK එකෙන් අපට ලොකු සපෝට් එකක් දුන්නා. අයියේ thank you කරපු උදව්වට. ඒත් එක්කම අපි විදිහට අපේ ටීම්ස් 4ක් එකතු වෙලා තමයි අද සෙෂන් එක කරේ. ඒ සෙෂන් එක ගොඩක් සක්සස්ෆුල්. ඉතින් ඒකට සපෝට් එක දුන්නේ ඕගොල්ලෝ. ඒකටත් thank you. ඒත් එක්කම අන්තිමට ප්‍රශ්නයක් අහලා තියෙනවා what is the best option when we join to the hub? Is it good to join for Sri Lanka or our own university one කියලා. It's better if you can join to your own university hub since then it could be easy to manage them also. And you can easily solve your problems from through your seniors then. එහෙනම් other session එක ඉවරයි.
Yeah, one thing Brian,
Yeah.
we will clear that ඔයාලගේ යුනිවර්සිටි එකේ හබ් එකක් ඔයාලා ඕගනයිස් කරලා තියෙනවා. ඒක රිප්‍රසන්ට් කරන්න අපි ගොඩක්ම ඒකේ හබ් එක දැම්මේ. මෙතන තියෙනවා ගොඩක් කැම්පස් ලැබ්ස් අපේම ෆොස් එකේම HashCode එක ඕගනයිස් කරන්නේ නැති. අන්න ඒ කට්ටියට සහ ෆොස් එකේ එක රිප්‍රසන්ට් කරන්න කැමති ඕනම කෙනෙක්ට ඕපන් කරලා තියෙන්නේ. අර යුනිවර්සිටි වලින් කට්ටිය හබ් එකක් තියෙද්දි ගොඩක් ඒ මාත් හිතන්නේ ඒක පාර්ටිසිපේට් කරන එක කිසිම ප්‍රශ්නයක් නැහැ. ෆොස් එකේ ඒකට අවශ්‍ය නැහැ. ඒ හබ් එකම පාර්ටිසිපේට් කරන ඔක්කොම අපි එකම කට්ටිය ඉන්නේ. එහෙම කිසිම ප්‍රශ්නයක් වෙන්නේ නැහැ. අපිට ඒතර මැනේජ් කරගන්න ලේසි. මොකද ඔයාලා අඳුරන කට්ටියම ඉන්නේ ඔයාලගේ ඔයාලට හෙල්ප් කරන්න. මේ පැත්තෙන් ඔයාලට ලොකු සපෝට් එකක් හම්බෙයි. ඒත් එක්කම මෙතන තව ප්‍රශ්නයක් තියෙනවා. ඒක මං උත්තර දෙන්න ඕන එකක් මට අමතක වෙච්ච දෙයක්. කෙනෙක් අහලා තියෙනවා දැනට හබ් එකක් නැති වුණත් රෙජිස්ටර් වෙලා ඉන්න පුළුවන්ද? ඔව් රෙජිස්ටර් වෙලා ඉන්න පුළුවන්. හබ් එකක් දැම්ම සිලෙක්ට් කරන්න ඕනේ නැහැ. ඔයාලට හබ් එකක් සිලෙක්ට් කරගන්න ඩෙඩ්ලයින් එක තියෙන්නේ මට මතක විදිහට 24 25 මන්තික. ඔව් ටීම් එකක් ක්‍රියේට් කරන්න හරි මොකක් හරි ඒ 24 25 ඔයාලට ෂෙඩියුල් එක ටිකක් බලා ගන්න පුළුවන්. ඒ වගේ දවසක නම් ඩෙඩ්ලයින් එක තියෙනවා. හැබැයි මම ඒක රෙකමන්ඩ් කරන්නේ නැහැ. මොකද there's our HashCode hubs also have a maximum team limit. අපි ලිමිට් කරලා තියෙන්නේ මොකද Zoom එකේ breakout rooms කරන්න පුළුවන් සීමිත ගාණක්. දැනටමත් අපි HashCode hubs ගොඩක් පිරලා ඉවරයි. ඒකයි පුළුවන් තරම් කිව්වේ අද සෙෂන් එකේදී ඉක්මනටම කට්ටිය ටීම් එකක් හදාගෙන රෙජිස්ටර් වෙන්න. මොකද පස්සේ ඔයාලා ජොයින් කරගන්න බැරි වුණොත් අපිට ඇත්තටම කරන්න දෙයක් නැහැ. මොකද අපිට මැනේජ් කරගන්න පුළුවන් රවුන්ඩ් එක තමයි අපි ගන්න බලාපොරොත්තු වෙන්නේ. මේ හින්දා පුළුවන් තරම් ඉක්මනට අදම මේ දැම්ම මම ලින්ක් එක දාන්න අර දාන්න දෙන්න g.co/hashcode ඕක කෝඩ් එක ගිහලා රෙජිස්ටර් වෙන්න ටීම් එක හදාගන්න හබ් එකක් සිලෙක්ට් කරගන්න වැඩ ටික කරලා තියාගන්න. මොකද ඉක්මනින්ම මම හිතන්නේ අපිට තව වැඩි කල් තියන්න වෙන එකක් නැහැ. රෙජිස්ට්‍රේෂන් ක්ලෝස් කරන්න මේ අපේ හබ්ස් වල. හින්දා පුළුවන් තරම් ඉක්මනට පාර්ටිසිපේට් වෙන්න මේ ඉන්න සෙෂන් එකේ හැමෝම අනිවාර්යෙන් පාර්ටිසිපේට් කරන්න ඒක හොඳයි. ඉක්මන් කරන්න. හරි බ්‍රෑඩ්.
So with that we are winding up today's session. Thank you all for joining with us today, and we hope to do more sessions about just like this in near future. And happy coding, everyone. Good night.
Yeah, happy coding. Good night.